Hello friends, today we are going to see how we can implement stack using queues. So we already know that what is the stack functionality, how it behaves, and also we know how the queue functionality works. So stack is last in, first out, and queue is first in, first out. Like when you add the last element, that will be the first element which we can take it from the stack. But in the queue, on the other hand, we have like first in, first out. Like what is the element which comes in first inserted the queue that is coming out, and how we can use using this, implement the stack using the queues, that we are going to see it on today's building. Before that, you can take an example of like now how stacks works and how queues works. So this is the queue where we have like first in, first out, like the element one is inserted first, the add it at the back side, and the element 2 is inserted second, and third is inserted second. When you take it out, you will get the element first out and second, and then 3. But on the other hand, when you take the stack, what is last comes first. For example, in this case, we have like stack number 1 is added at the stack at the lowest level, and then on the top there we added the number 2, and on the top we have added a 3. So when you take it out, so we will insert the last element, that is 3, which is coming out first. So we are going to see how we are going to use implement the stack using the queue. So how we can do it? Let me walk through the code. Some of the functionalities are similar, which will have like the same results which stack is having, that same as queue, but only something is like, it's a difference. So we are going to see it by that. So I can declare a queue now. So I'm initiating the queue. So if it is empty, we just check it whether the queue is empty. We're just going to check the queue. Is it empty or not? So we just return that value here. So that will result, and this function will cover like, okay, the queue is completely empty. So then we are going to just return that one. Okay. Now we are going to see what is the top element in the queue. So that's the peak element in the queue. Okay. So in stack, when you call the stack here, we will just return the number. It will not remove from the stack. It will just return the number. Same here, when you call the peak, it just return the top element. What is that top element? Which is nothing but what is there in the stack. What is the top in the stack? The similar function, we have it in the queue here. So that returns the top number, but it will not remove from this stack. Same here, it will return the peak element. It will not remove from the queue. It just return the first element on the first element from the queue. So which is similar functionality. We are going to use it in the stack. Okay. So now we have to pop it up. Pop it up is something from the stack which will remove the element from the top. So whatever the last in, first out, when you call the pop, it will remove the element and it will just return the results. So here what we can do here, when you call the remove method, the last element from the top, from the stack, it will be removed. When you call the remove, the first inserted element from the queue will be removed. It's a similar functionality. So now we have an important functionality here, push. How do you achieve like last in, first out using queue, which is first in, first out? For example, if you take like this, if queue is empty, so we don't think about like how many elements are there. If it is empty, we just have to push the X. So it's just pushing the element because this is the first element. No matter what it is, last in, first out, or first in, first out, it just have one element. If the queue is empty, so it gives the same result. Suppose if the queue is not empty, like we have like some other elements are already added in that, how it behaves in the stack. For example, we have to take the queue size now. So how we are going to achieve here is, for example, we have a queue here, 1, 2, 3, 4. This is one queue. So this is the existing queue. So now we are going to add one more element here. For example, 5. So we are going to add this 5 into existing queue. So as a result, what it will do is 1, 2, 3, 4, 5. So the new element is added here. So this is general queue behavior. What is first in, first out? When we add, it will have a head portion and it will have a tail portion. So whenever we add a new element, then it will be added in the tail portion. So how we can convert this into stack is when you reverse the queue. So what will, when we reverse the queue, what will happen here? When you, after adding the element, when you reverse the queue, what will happen here? 5, 4, 3, 2, 1. So we get the result like this, which is nothing but how it behaves in the stack. So that is the one we are going to add it whenever we are pushing an element. We just take the size and we added the element and then we reverse the queue so that it will behave the stack functionality. So that is what we are going to do here now. So we have to go take the size of the queue. Size. And we are going to add the element, the queue element, the new element into queue. So after we adding it, we are just going to reverse it. Reverse the queue. How we can do it? Size is, we are going to iterate backside. So we're going to add from the first element. So just looking through and we are decrementing the size. So in that way, we are just reversing the queue after adding the element and reversing the queue. So we can achieve the stack functionality in this case. So if you, let me run this code and see what we do. Queue.peak. So yes, we got the runtime of 0 milliseconds. So you can see here, let me submit this and see if it works. Yes, we got the 0 millisecond faster than 100% Java online submissions using implementing like stack using queue. So queue's functionality is first in, first out. Stack functionality is last in, first out. So we are implementing using queue and we are just adding it and reversing the queue. That makes it behaves like the stack. So I hope you understand this concept, and it's important questions asked by big companies like Amazon. It is frequently asked, the question asked is, and it's very easy also. And we just understand the concept. Once we get it, and we just easily implement this, and it won't take much logic or like, we just have to understand how we are reversing the queue to make to available like how it behaves the stack way. And I hope you enjoyed this video. If you like the video, please like it, share it, and subscribe it. Thanks you. Have a wonderful day. Thank you.